Hello, hello everyone, and let's get started. So today I'm going to, well, certainly not introduce you to, but we'll get a little glimpse into solving equations. Well, of course, you know how to solve equations, but hopefully I can introduce some interesting, unusual equations which you probably haven't met before, and some techniques how to solve equations. Okay. This is in no way an exhaustive list. I'm just showing you some of the techniques. Some of them will be some of them have been covered in previous webinars. So if you go back a year into last year's webinar, there are two webinars on equations. So hopefully you can pick some interesting stuff there. So today we'll be covering substitution. We'll be covering well, using properties of functions, so using monotonic tonic functions, and we'll be talking about the modulus, and we will be talking about modulus equations, and we'll be talking about parameters, equations with a parameter. So this is the plan for today, and all right, let's get started. So question one looks scary. Which do you think? Which option do you think it is? Which of the methods? Well, obviously, there's a hint. It's the top one. Yeah. So you can notice that they're the same expression you see twice. So you would say, okay. So I'm going to make t is equal to 25x squared minus 10x minus 8. And then you can write the equation as 2 over t plus t over 2 squared equals 4. Okay, so that's already much simpler. Now you could open the brackets. What do you think a problem is with opening the brackets? What if we open the brackets? It gets really complicated because look, if I open the brackets, it gets 4 over t squared plus 2 multiplied by 2 over t times t over 2 plus t squared over 4 equals 4. But then there's a problem because you have a denominator, and to get rid of the denominator, you multiply everything by 4t squared. And the moment you do that, the equation stops being quadratic and becomes a quartic equation, which you really don't want. Okay? I mean, in this particular case, you could do that, and it's not that bad. I'm looking at it and I'm seeing it's not that bad, but it becomes 16 plus 8t squared plus 4t to the power 4 equals 16t squared. Okay, so obviously not bad. You can solve that. Yes, solve. But also, you could just say, well, if something squared is 4, that means that something is plus or minus 2. So we can say 2 over t plus t over 2 is 2, or 2 over t plus t over 2 is minus 2. A substitution using monotonic functions. I wouldn't say there are 4 methods. There's just 4 things we'll be covering. And this gives you two equations, and you can solve them. You can multiply each by 2t. So that's times 2t, and that's 4 plus 2t over 2. So that's t squared equals 4t. So t squared minus 4t. Geez. And here it's t minus 2 squared, where I can complete the square here, or just factorize. So t equals 2. Or, so if I multiply this by 2t, I get 4 plus t squared equals minus 4t. And then it becomes t squared plus 4t plus 4 equals 0. So t plus 2 squared equals 0. And yeah, square root and factorize. Square root and factorized. Well, is that what you meant? Yes, you can. That's exactly what I'm doing. T equals minus 2. Okay, so we got 2 equations. It's either t equals 2 or t equals minus 2. Okay, and now we remember that t was a substitution. So t is 25, but t is 25x squared minus 10x minus 8. And that means that 2 equals 25x squared minus 10x minus 8, or minus 2 equals 25x minus 10x minus 8 squared, of course. All right, solving this quadratic equation, 25x squared minus 10x minus 10 equals 0, divide by 5, so 5x squared minus 2x minus 2 equals 0. X is 2 plus or minus square root b squared, that's 4 plus 8 times 5. 8 times 5 is 40. Oh, that's not pretty, but okay. Over 10. And here we have 25x squared minus 10x minus 6 equals 0. That doesn't look pretty either. Okay, they've not made it easy for us. So x is equal to 10 plus or minus square root of 100 minus 6 plus 600. Okay, divided by 50. So x is 2 plus minus 4, so that's 2 root 11 over 10, and this is 10 plus minus 10 root 7 over 50. So x is 1 plus minus root 11 over 5, and x is 1 plus minus root 7 over 5. Okay, not bad. Okay, so these are x1 and 2, x3 and 4. Those are the answers. Okay. Next question. Okay. Well, there's not much you can do here. You need to find the common denominator. Right, so let's do that. The common denominator is x minus 2 times x minus 3. So you have to mention that x is not equal to 2 and x is not equal to 3. We have to keep that in mind just because, so this is the domain of the equation. Because you cannot divide by 0, so these things cannot be, x is not 2 and x is not 3. Okay, so I'm going to multiply the first fraction by x minus 3, I multiply the second fraction by x minus 2, and I multiply the x by x minus 3, x minus 2. Let's see what I get. I get x minus 3, x squared minus 2x minus 1, plus 2 x minus 2, and that equals x minus 3, x minus 2. Now, of course, I have the common denominator, which is x minus 2, x minus 3, and x minus 2, x minus 3 here. But I can remove that because two fractions are equal if their denominators are equal and their numerators are equal. The denominators are equal. So for that, we keep this in mind so that we can actually just remove the denominators. And opening the brackets, so x cubed minus 2x squared minus x minus 3x squared plus 6x plus 3 plus 2x minus 4 equals x, open bracket, x squared minus 5x plus 6. If I make a mistake, please let me know. And this can be written as x cubed, x cubed minus 5x squared, 6x. So I can delete that. X cubed goes away, thankfully, and we are, and 5x squared goes away. Nice. And 6x goes away. Okay. So we get minus x plus 3 plus 2x minus 4 equals 0. So x minus 1 equals 0. X equals 1. We do not have any complications here. So that's it. That's the solution. They're pretty straightforward. I thought it would be harder. Okay. Right. So we'll see some techniques, but first I want to talk about the modulus. And to talk about the modulus, I think a good way to start is the modulus graph. The modulus, as you probably know, makes everything positive. So any number you give to the modulus, it spits out a positive number. So for example, if you have x, well, just modulus 3 is 3. Modulus minus 5 is 5. Modulus 0 is 0. In other words, modulus x is the distance from 0 to x. If you think about it. And to draw a graph, well, you can simply do the table, like xy table, to do the graph. So if x is 0, it's 0. If x is 1, is 1. 2 is 2. Okay, that's fine. Then, etc. What if it's minus 1? Minus 1 is 1. Minus 2 is 2, etc. So it looks like the graph is going to look like this. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, minus 1, 1, minus 2, 1, Okay. So this is the graph y equals modulus x. This is x and this is y. Okay. Did you know the shape of this graph before today? 1 for yes, 0 for no. Okay, that's good. Okay. So yeah, this is the modulus graph. Now, the modulus has a definition, and let's explore the definition of the modulus. Definition of modulus. Modulus x is equal to x if x is positive or 0, and it's equal to minus x if x is negative. If you think about it, that makes sense. This is the symbol for or, mathematical symbol for or. If you see a square bracket like that, that means or. You won't see it in A level, you won't see it in GCSE, but you might see it in the future. So that's the definition of a modulus. Let's try to make sense of it. So we have a function, y equals modulus x. If you use the definition, that literally means like if x is positive, then y is equal to x. And if x is negative, y is equal minus x. These are two graphs. So x is positive. So where is x positive? So this is the xy plane. And so x is positive. So this is 0. So x is positive here. So that's x is positive. And now if you ask what is x negative, negative x is here. Oh, okay, they're bad color to use. Green. This is the region where x is negative, right? X is negative. Does that make sense? Positive x's, negative x's. All the positive x's are on the right, all the negative x's on the left. But it says the graph is y equals x. The y equals x is this graph. This is the graph y equals x. Y equals x. Well, it continues that way, but we're not interested in that section because we only draw it when x is positive. So it stops when x becomes 0. And y equals minus x, it's this graph. Y equals minus x. Y equals minus x. That's it. That's how we get the graph. Right? So basically what that means, what the definition means. So y equals modulus x matches y equals x for positive values of x. Sorry, positive value, and it matches y equals minus x for x less than 0. Does that make sense? Do you understand what I'm talking about? So the graph of y equals x, it is the same as the graph of y equals x when x is positive, and it's the same as the graph of y equals minus x when x is negative. Do you understand? Do you understand that? Maybe on a scale of 0 to 10 would be a good way to. Okay. All right. So let's look at the second graph and also use the definition. So using the definition of the modulus. So y equals modulus x minus 2. So we know that y equals modulus x minus 2. Yeah, depending on the value of x. We know that this is x minus 2 if x minus 2 is positive. And it's equal to minus x minus 2 if x minus 2 is negative. But let's write that, let's simplify that a little. So x minus 2 is greater than 0, so that means x is greater or equal to, right? This literally means x is greater than 2. And it's open bracket minus x plus 2 if x is less than 2. Okay. So x and y. So it says when x is more than 2, so this is 2, x is more than 2, more than that, the graph is x minus 2. So y equals x minus 2. So we draw the graph of y equals x minus 2. So that's the graph. It's going to be like this. So that's y equals x minus 2. And then when x is less than 2, it's the same as the graph minus x plus 2. Minus x plus 2, so that's the intercept. So that's going to be like this. And that's the shape of the graph. We can delete this. We can remove this. That's the graph. So this piece of the graph is y equals minus x plus 2. But overall, that is the graph is y equals modulus x minus 2. Okay. You could also think of it as it's a graph, it's the modulus x but shifted to the right. Okay, let's look at this graph. Now, we need a little bit of ingenuity here. Well, okay. We know that modulus x plus 2 is x plus 2 when x is greater or equal minus 2. Okay, it's very important that you understand this part. So on a scale of 0 to 10, do you understand this, what I've just written here? Especially this part. Okay, good. And it's minus x minus 2 if x is negative, if x is less than negative 2. And then x minus 2. X minus 2 is x minus 2 if x is greater than 2. And it's minus x plus 2 if x is less than less than 2. Sorry. And we kind of have 4 scenarios. So case 1. That means both of them are true. So x is greater than minus 2 and x is greater than 2. And that means that y, the function, so they're both positive. So that becomes x plus 2 plus x minus 2. So that's 2x. Y equals 2x. Case 2. Should they do them vertically? Yeah, let's do them vertically. Case 2. That's 2x. if x greater than -2, but x is less than 2. So that is x, y is x plus 2 minus x minus plus 2. So that is just y equals 4. Y equals 4. And here y equals 2x. Now, if you combine these two, you understand that if x is more than -2 and x is -2, so that's just x greater or equal to 2. And this is just x is less than 2, but greater or equal -2. Case 3, x is less than -2, but x is greater than 2. That's impossible. You cannot have less than 2 and greater than 2 at the same time. And case 4, x is less than -2 and x is less than 2. That means it's just simply x is less than -2. And the equation becomes y equals -x minus 2 minus x plus 2. So 2 cancels and you get y equals -2x. So effectively, considering all these cases, we have y equals x plus 2 plus x minus 2 is equal to, it's equal to 2x if x is greater than 2. It's equal to 4 if x is between 2 and between -2 and 2. And it's -2x if x is less than -2. And we can certainly draw this graph now because we know how to draw straight lines. So this is x, this is y, this is 2, this is -2. So between -2 and 2, that's simply 4. So that's 4. So the graph goes like this. Now, for values greater than 2, it's 2x. So that's this graph. So it's simply this section here. Y equals 2x. And it's this graph here, y equals -2x. Let's check if we got it right. So y equals modulus x minus 2 plus modulus x plus 2 dash. And indeed, here is the graph. All right. So I hope you liked that. If you understood the method, then you have a very powerful method on your hands. Now, I have to say that this method is not covered in GCSE and it's not covered in A-level either. They use a different method, which it may be good, maybe not. What they do is just they square it. So rather than using the definition in an A-level paper, you would just square both sides. The problem is that you get huge powers. Yes, you are taught how to solve these at A-level, but you can avoid using higher powers. So using the definition of the modulus, we say that modulus x minus 7 is either x minus 7 when x is greater than 7, and it's minus x plus 7 when x is less than 7. So you have two equations. So you have case 1, assume that x is greater than 7, and then the equation becomes x minus 7 equals 3x squared plus 4x minus 1. 3x squared plus 3x plus 6 equals 0. X squared plus x plus 2 equals 0. Tempted to complete the square. Obviously, that's not necessary. Oh, it has no solutions. Have I made a mistake? 3x squared plus 4x minus 1. 6, 3. 3x squared plus 3 plus 6 divided by 3, x squared plus x plus 2. Oh, no real solutions. So the discriminant is less than 0. So no real solutions. No real solutions. It's kind of it's a bit what's the word? Disappointing. X plus 7. So now we say, what if, let's assume now for that x is less than 7. So then the equation becomes minus x plus 7 equals 3x squared plus 4x minus 1. So 3x squared plus 5x minus 8 equals 0. So it's a special case, right? If you remember the special case that x1 is 1 and x2 is minus 8/3. And both of these are less than 7. Both are less than 7, so both are acceptable. So the answer is x1 equals 1, x2 equals minus 8/3. Let's check graphical method. So to do it graphically, you just draw the left-hand side and the right-hand side separately. So you get y equals modulus x minus 7. That's the first graph. And then y equals 3x squared plus 4 minus 1 plus 4x minus 1. So you can see that the intersection is 1 and minus 8/3. Modulus on the keyboard. For me, it's next to Z, but it can be different on different keyboards. I have an old-fashioned keyboard, so this is Z, and it's right next to it. It might be different for you. Okay. I think I bought the keyboard for like £3 10 years ago. I'm still using it. I like the clickety-clack sound. Okay, problem 5. Now, problem 5, we can't use the same technique here. Well, we can, but it's going to be complicated because in order to do this, you can say that x squared plus x minus 3, you say, well, it's either x squared plus x minus 3 when x squared plus x minus 3 is greater than 0, or it's minus x squared minus x plus 3 when x squared plus x minus 3 is less than 0. It requires you to solve two quadratic inequalities with roots which will look horrible, basically. So in this particular situation, you wouldn't use the definition, like too complicated. Too complicated. Okay. Let's look at some other things. Like, what if I get us to look at a super simple equation? So consider a super simple equation. I'm just going to write modulus x equals 3. I mean, in a way, these two equations are equivalent. Well, they're sort of the same thing. Well, if modulus x is 3, what is x? Yeah, 3 or minus 3. So x is plus or minus 3. I'm going to generalize this. I'm going to say that modulus f of x, if modulus f of x is equal to g of x, right? Then f of x is plus or minus g of x as long as g of x is non-negative. No, you need a figure bracket, and. Because if this number were negative, there would be no solutions. Okay. To understand what I've written here, let me just make. So let's say modulus x is equal to a. That means x is plus or minus a, but a has to be non-negative. Because if a is negative, then this is impossible. Modulus cannot be equal to a negative number. Does that make sense? And this is the general version of the same thing. If you have a question, please ask me. Hopefully that makes sense. So using this method, well, let me just be a bit lazy. Copy. Okay. I'm going to say that, so using this method, I'm saying, look, this is equal to that. That means either x squared plus x minus 3 is plus or minus this thing, as long as this thing is positive. So minus 2x plus 1 has to be non-negative. And that's important. So from here, I have two equations. I can solve the bottom inequality, and that's so x squared plus x minus 3 equals minus 2x plus 1, or And here I have x minus 2x greater or equal minus 1. And that means 2x is less than or equal 1. X is less than or equal half. So, or x squared plus x minus 3 equals 2x minus 1, and x is less than a half. And now if I solve these, so x has to be less than a half, so x squared plus 3x minus 4 equals 0, and x is less than a half. That means x is, well, 1. It's a special case, 1, or x is minus 4. But at the same time, x has to be less than a half. So that means that x is minus 4. Because 1 is not suitable. X, that's a contradiction. X cannot be 1 because x has to be a half. And here, a very similar thing. So x squared minus x minus 2 equals 0. It's another special case. So x is less than a half. So x is minus 1, or x is 2, and x is less than a half. So 2 is not suitable. So x2 is minus 1. So you have two solutions. All right, answer. X1 equals minus 4, x2 equals minus 1. Let's check. Right, so y equals modulus x squared plus x minus 3. Minus 3. Okay, interesting graph, by the way. And y equals minus 2x plus 1. Y equals minus 2x plus 1. And you can see that there are 2 points of intersection. So, indeed. So we have minus 1, and we have minus 4. Okay, and this is y equals minus 2x plus 1, and this is y equals modulus x squared plus x minus 3. Okay, nice. Problem 6. Well, here, just it's another method. Is a modulus of this is equals to modulus of that. Well, if you think about it, like if you say modulus x equals modulus y, well, there are two options. So first of all, there are no limitations. They can be both positive or negative. And that also means that they have either they're both. So that means that either x is y or x is minus y. If you think about it, it has to be true. So because, for example, modulus 3 is modulus 3, or modulus 3 equals modulus of minus 3. Yeah, that's an example. So in general, if you have modulus f of x equals modulus g of x, that means that f of x is equal to plus or minus g of x. But So it's very similar to the previous case, except there are no limitations here. Great. So that is that means we have 3x minus 2 equals 2x minus 3, or we have 3x minus 2 equals minus 2x plus 3. So basically minus that. And that's it. Those are the two options. So x equals minus 1 and x equals 1. Ooh, interesting. Minus 1 and 1. They both 1 and 2. They both should fit, and we can 3, 2, 2, 3. So let's double check. Y equals modulus x minus 3x minus 2, and y equals 2x minus 3, and one and minus 1. True. Quite straightforward. Okay, so in this example, this problem, we're going to use the monotonic property. Monotonic property. Now, it's quite difficult solving this equation because you have to square it and then you have to square it again. Okay, so to do it algebraically, you have to square it, and that would be 2x, so square both sides, square both sides. So method 1. A method both sides, but that doesn't get rid of the square, so separate, square again, and then solve the equation and check, solve and check, and check. So that would look something like this. So squaring both sides, squaring both sides. Okay, it wouldn't be the end of the world if you square both sides. 2x minus 3 plus double 2x minus 3 square root 4x plus 1 plus 4x plus 1 equals 16. And then you get 2 square root of 2x minus 3 square root of 4x minus plus 1 equals 16 minus 6x plus 2, so that's 18. And then you square both sides again because you still want to get rid of the square roots. So you square it again, and then you get something. You get a quadratic equation which is solvable. But in some cases, it's not. Okay. So method 2 requires some ingenuity. So let's try to guess a solution. Oh, 0 doesn't work. 1 doesn't work, so it has to be more than 1.5. So 2. Oh, 2 is a solution. Good guess. Is a solution. I just checked it and it worked. Hooray, hooray, hooray me. Okay, you can do trial and error. You can do trial, so guess a solution by trial and error. How do you prove that it's only one? No. You well, yeah. Well, you substitute and it's true. How do you know that's the only solution? How do you know that there like x equals 17.3 is not a solution? Discriminant. You could. You could. There's lots of methods. Discriminant would be quite hard. You could, yeah, you could do the discriminant. Actually, I think the discriminant would be positive. So I think you get two solutions, but you have to eliminate one of them. So that won't work. The method that I want to use is using the monotonic property. What is monotonic? A monotonic function that is always increasing or always decreasing. Monotonic means always increasing or always decreasing. Means sloping downwards. And we know that the square root function is a sloping upwards function. Square root of 2x minus 3 is a function that slopes upwards. We know how it looks like. It looks something like this. Y equals square root of 2x minus 3 is monotonic increasing. And y equals square root of 4x plus 1 is a very similar function. It's a square root function. It's always an increasing function. Y equals 4x plus 1. It's an increasing function also. So monotonic increasing. Now, the sum, that means y equals square root of 2x minus 3 plus square root of 4x plus 1 is a monotonic increasing function. Monotonic function. Monotonic increasing function. All right. Okay. What are we comparing it to? We're comparing it to y equals 4. Y equals 4 is a horizontal line. Y equals 4 is a horizontal line. So we have x, we have y. We have an increasing function, which is always increasing, and we have the line y equals 4. How many intersections can it have? It can only have one intersection. Therefore, and we found it, it's x equals 2. Job done. We just guessed a solution, and we look at the left-hand side of the equation, it's always increasing, and we look at the right side, it's constant. They can only meet once. So a constant and an increasing can only meet once. Only meet once. And if you guess it, if you're lucky enough to guess it, that's it. That's your solution. Okay. All right, makes sense. No questions. Okay. Next one. Now this one is coming back to this. It's also important when you do the method one. You also need to consider the following. You're taking the square root. The square root has to be you can't take a square root of a negative number. So you have to consider the domain as well. Domain, the 2x minus 3 has to be non-negative. That means 2x is greater or equal to 3, x is greater than 3 over 2, and 4x plus 1 has to be greater or equal to 0. So 4x greater or equal minus 1. So x is greater or equal minus 1/4. We already know that x is greater than 3 over 2, so this is a bit pointless. So we have to say that x is greater or equal 3 over 2. And what you get here, when you solve this one, you would probably get two solutions, and one of them will not satisfy this equation. So that's how you get only one solution. Now, looking back at this, so this equals to that. Well, what do we see here? Well, first of all, we can't take the square root of a negative number. So we have to say that 2x squared minus 8x plus 9 has to be positive. Secondly, x minus 1 is equal to the square root of something. That means x minus 1 has to be positive as well. Because you can't have like square root of something equals minus 7, right? That's not possible. Therefore, x minus 1 has to be positive. Now, you could solve the quadratic inequality here, but it's a bit too complicated. So I'm just leave it for now. But let's do this one, of course. So x is greater or equal to 1. And that's an important, x can only be greater or equal to 1. Now, this one we can check later. We can check the answers and see if this is also true. It's a bit too complicated to try and solve it straight away, and perhaps unnecessary. Actually, you know what? I'll just double check. I don't think it solves nicely. 2 minus 8, 9. Oh, it doesn't solve at all. It has no roots, so that's always true. Always true. Because the discriminant is less than 0, so it's always true. So we don't care about this one. All right, so this is important because when we get the solution, we need to check it against that. All right, square both sides. Both sides. And we get 2x squared minus 8x plus 9 equals x squared minus 2x plus 1. X squared minus 6x plus 8 equals 0. And then we have x minus 4, x minus 2. Oh, x1 is 4, x2 is 2. And there are no contradictions, so both of them are valid. So that's the answer. It doesn't contradict the x greater than b equals 1. It's a bit disappointing, but k squared of 2x squared minus 8x plus 9. Yeah, I can imagine that. Let's see if y equals square root 2x squared minus 8x plus 9. Right, and we have y equals x minus 1. Oh, so yeah, we have two intersections. So 2 and 4. Good. An interesting graph, by the way. Would be interesting to explore why does this graph has a shape like that. I'll leave it to you. So that's the homework to explore. So homework, try to understand why the green shape graph has this shape. It's like a parabola, but it's not. It's more like a straight line. It's more like two straight lines, but here it curves towards the middle. So interesting. Okay, last question for today, and it's a parameter. It's a question with it's an equation with a parameter. Equation with a parameter. Equation with a parameter. So A is the parameter in this particular case. And find all values of A so that the equation has exactly 2 roots. Or something tells you that somebody give me a hint, which is hinting 2 roots, something that's a bit like a quadratic, yeah? Yeah, discriminant is positive. No, but we have a modulus here. So first using discriminant. Now, if we try do this, so we have to consider that, well, there are 2 cases. Modulus x is equal to x if x is positive, and minus x if x is negative. So we have to say x squared minus 6x minus a plus 6 equals 0. And x squared so if x is greater than 0, then it looks like this. And if x is less than 0, it looks like x squared plus 6x minus a plus 6 equals 0. So the discriminant here is b squared minus 4ac, so b squared, which is 6 squared, minus 4 times minus a plus 6. And here the discriminant is 6 squared minus, okay, so a minus 6 plus 6. It's the same discriminant. But even if the discriminant is positive, that doesn't mean it has 2 roots. Why? even if discriminant is positive, no, if discriminant is greater than 0, roots are different. But look, what if one of the roots is negative? That means it won't work. You might, even if you might not have two roots. Okay, you might not have two roots because as one of them might be negative. Um, so yeah, using discriminant, it gets really complicated really quickly because you have to consider, okay, you found the discriminant as 36 plus 4a minus 24. So that's 12 plus 4a. So that has to be greater than 0. So a has to be less than 3. And here, a has to be less than 3. But then you have to find the x, because x1, 2 is equal to 6 plus or minus square root of 12 plus 4a divided by 2. You have to check that they are positive. Basically, what you'd have to check that this value does not exceed 6. So that gets complicated. I hope you see that it gets really complicated because there's so many factors are in play. Discriminant has to be positive, but then the roots have to be positive. But then you have two roots here and two roots there, so overall that's 4 roots. So there's so many things to consider. So even though this method is usable, it gets I think it's too complicated. Because you have two roots here, but you also have roots 3 and 4, which is 6 minus 6 plus or minus square root of 12 plus 4a divided by 2. So, I mean, I could solve it for you. I won't. Has to be negative. That's important. Anyways, the second method is graphical solution. In a graphical solution, you write down x squared minus 6 modulus x plus 6 equals to a. Ooh, nice. And we consider the two graphs. We draw two graphs. Y equals x squared minus 6 plus 6, and y equals a. All right. This graph. Well, we know that this graph, x squared minus 6 modulus x plus 6, we know that it's equal to x squared minus 6x plus 6 if x is positive, and it's equal to x squared plus 6x plus 6 if x is negative. And this is just y equals it. It's a horizontal line. Horizontal line. Okay. Okay, so this graph. So let's complete the square. X minus 3 squared minus 3. And this is x plus 3 squared minus 3 if x is greater than 0, if x is less than 0. So if x is greater than 0, then it has a vertex at 3 minus 3. So it goes like this. And 1, 2, 2. Okay. I'll need to move it. Okay. So this graph is when x is positive, the graph is like this. Okay, this point is 1, 2, 3, 4, 5, 6. That does make sense. When x is 0, it's 6. 6 is the y-intercept. But this is only for the positive axis. For the negative axis, it's a different parabola. So it has a vertex at minus 3, 3, minus 3, minus 3. And this is 3 minus 3. And then it has same kind of points. So it goes like this. Okay, nice. So this graph has two sections. When x is positive, it's like this. It matches this parabola. And when x is negative, it matches this parabola. So y equals x squared minus 6 modulus x plus 6. This is the graph. The second graph that we need to draw is y equals a. Oh, y equals a is a horizontal line. Well, this, for example, this is y equals a when a is 2. A is 3. A is 5. A is 6. A is 8. And a is minus 3. So for which values of a do we have exactly 2 roots? Is that the only option? Yes. So we have 0 roots if a is less than minus 3. We have 2 roots if a is minus 3 or a is greater than 6. We have 3 roots if a is 6, and we have 4 roots if a is less than 6 and more than -3. So the answer, A is -3 or A greater than 6. That is the answer. Pretty cool. So graphical solution is preferable in this particular case. One more thing I probably want to show you. Let's call it problem 10. Draw the set of points which satisfy modulus x plus modulus y equals let's do one easy. Now, using the definition, modulus x is x if x is positive, and minus x if x is negative. The same for y, equals y if y is positive, and minus y when y is negative. So that means we have 4 possibilities. If we draw them on the graph, x and y. X is positive, so here x is positive and y is positive. Here x is negative and y is positive. X is positive, y is negative. X is negative, y is negative. So let's call it 1, 2, 3, 4. 4 cases. In case 1, the equation becomes x plus y equals 1. In case 2, when x is negative, it becomes minus x plus y equals 1. In case 3, both negative, minus x minus y equals 1. And in case 4, x minus y equals 1. And so from here, we can rewrite that as y equals minus x plus 1, y equals x plus 1, y equals minus x minus 1, and y equals x minus 1. And if we were to draw these, so let's call this 1, 1, 1. So that's 1, 1, minus 1, minus 1. So in the first case, it is y equals minus x plus 1. It's a sloping downwards graph, gradient minus 1, intercept 1. So it goes like this. But it has to stop because we can't cross this boundary, because that's where x is positive and y is positive. In the second case, first case, case 2, y is x plus 1, so intercept is 1, gradient is 1. So it looks like this. And if this is true, then minus x minus 1, so it's this graph and this graph. So this shape has the equation modulus x plus modulus y equals 1. Neat. And if you know, you probably do, that if you have x squared plus y squared equals 1, that's a very, well, it's somewhat similar shape, just curved. Cubed. Okay. What's x x4 plus y4 plus 1 equals 1. I don't know. Check it out. Okay. So hope you enjoyed that. I hope you found it useful. Please do go back to my previous webinars. And yes, I think most method will score you marks, except if you just use an equation solver. Question 8. Oh, can you just use the link, please, Wendy? So just use the link and you can see all the questions. Ah, yes, thank you. Thank you, George. That does, that's what I expected. Try square root of modulus x plus square root of modulus y. You get something else entirely. All right, I have to go. So I'll see you all next week, I think. Just a second, just double checking. Webinars. 10th, yes, 10th of February. All right, see you all. Bye.